This is Bergamo, and this is his racehorse Poop. Unfortunately, Poop sucks monkey balls and he fucking dies. Luckily, Bergamo also has 25 other horses, and he's gonna try to find the top 3 fastest horses to replace Poop. All 25 of these horses run at a different speed, and luckily, Bergamo has a 5-lane track in which he can race 5 horses at a time to determine who's faster. So our question for today is, what's the minimum number of 5-horse races to determine the top 3 fastest horses out of the 25 horses? So to start, we know that in order to determine the top 3 fastest horses, we must see every horse run at least once. So what's the best way to do that? Well, that's just to have 5 rounds of races just to start and have all 25 horses race. So those will look like this. So our first race will be the first 5, the second race will be the next 5, and so on. And that will be 5 total races to determine an initial ranking. So let's imagine the outcome of those races end up like this. And keep in mind that these numbers that I chose to win each race is kind of arbitrary, and these numbers can be swapped around however. But this is just a case that can be applied generally and will help you understand the logic. Now, looking at these standings of these 5 races, the first thing we want to notice is that if you finished 5th or 4th in any of these races, that surely means you cannot be one of the top 3 fastest horses. Because if you're not even the top 3 fastest in your own race, how can you possibly be the top 3 fastest in all the horses? Now, looking at the remaining 15 horses, we can't really get a gauge on which ones are the top 3. And that's because we don't have any comparison across races. For example, these 3 horses might be the fastest out of all of them, but we don't know that until we compare against all these other races. So what do? We should race the fastest horse out of each of these 5 races just to see how these races stack up against one another. So that's going to look like this, and let's imagine that the outcome is like this. And again, this outcome is kind of arbitrary. You can swap around the numbers of the horses and the logic will still be the same. So this now tells us a few things. Well, the first thing we know is that these 2 horses cannot be the top 3 because they finished 4th and 5th in a race against other horses. And by the same logic, since these 4 horses are slower than these 2, none of these horses can be top 3 either. Now we're left with these 9 horses. And we know that since this horse won its race and won the race out of all the winners, this is the fastest horse. So we're trying to figure out the next 2 fastest horses. We also know the best this horse can do is end up in 3rd place. And since this horse was faster than these 2 cannot be in the top 3 either. And now, by similar logic, we know the best this horse can do is place 2nd, which means the best this horse can do is place 4th, so this horse also cannot be top 3. So finally, all that's left to do is compare these 5 horses, and the top 2 out of this race will be our 2nd and 3rd place. Thus, our final race will look like this, and this will be our 7th total race, which answers our question, what's the minimum number of 5-horse races to determine the top 3 fastest out of 25 horses? The answer is 7 races.